For today's video, we are going to have a practice problem on how to solve geometric probability, and we are going to explain in details how do we get the answer. So let's start with the first example. If AD is 20, AB is 8, and CD is 7, what is the probability that a point chosen at random on segment AD will be located at BC? So let us illustrate first the given. If we are going to have a line and all points are listed in alphabetical order, so this will be point A and this will be point D. Point B is somewhere here and this will be point C. The distance between AB, that is 8, and the distance between CD, that is 7, and the total distance between A and D, that is 20, and to find the distance between B and C, we are going to have 8 plus 7, that is 15, and then 20 minus 15, that is 5, and that is the measure of the distance of BC. Now, to find the probability of the given problem, the probability is equal to the number of successful events divided by the total number of possible outcomes. But for the line and segment, the probability will be, let's have P, length of the successful line over total length. Since we are looking for the location of BC, BC will be 5 and total length will be 20. If you are going to simplify this one, this will be divisible by 5. It will become 1 over 4. And this will be our answer. And if you are going to find the probability of AB, we are going to have probability of AB, that is length of AB over total length. So this will be 8 over 20, or can be written as 2 over 5. This will be our answer. And if you are looking for the probability of CD, this will be the length of CD over total length. So this will be 7 over 20. And this will be our answer. On example number 2, point R is randomly chosen on segment AC. What is the probability that it is chosen within 6 units of B? As you can see in our illustration, point A is located at -5, point B is located at +3, and point C is located at +7. To find the probability that R is chosen within 6 units of B, let us use the formula. Probability is equal to the length of the successful line over total length. So let us find first the measure of the total length. Since A is located at -5 and C is located at 7, let us have 7 minus -5. It will give us +12. So therefore, the total length will be 12. Now, the location of point B is +3. 6 units to the left will give us -3. 6 units to the right will give us +9. That is 3 minus 6 is -3. 3 plus 6 is +9. But point R is chosen between A to C. So therefore, to find the probability that R is chosen within 6 units of B, we are going to have 6 units to the left and 4 units to the right because 9 is outside of AC. So therefore, to find the length of the successful line, we are going to have 7 minus -3, and that is +10. So this will be 10 over 12, or can be written as 5 over 6, and this will be our answer. On example number 3, point X is randomly chosen in the rectangle shown below. What is the probability that point X will be located within the triangle? So as you can see in a given figure, the triangle is inscribed in a rectangle, and the dimensions of a rectangle will be 5 and 6 units. and the dimensions of a rectangle will be 10 and 6 units long. Now, to find the probability, let us use the formula. Probability is equal to the area of a triangle divided by the area of a rectangle. Now, let us find first the area of the triangle. The area of triangle will be 1/2 base times height. So this will be 1/2 times 5 multiplied by 6. So 1 times 5 times 6, that's 30. Divide by 2, that is 15 square units. So this will be the area of the triangle. And to find the area of a rectangle, this will be base times height, and that is 10 times 6, that is 60 square units. And to find the probability, this will be 15 over 60. Since 15 and 60 are divisible by 15, so 15 becomes 1 and 60 becomes 4, and this will be our answer. On example number 4, point X is randomly chosen inside a cube with a length of 12 inches. A hollow sphere with a radius of 5 inches which is located inside the cube. What is the probability that X will be chosen inside the sphere and outside the sphere? So let us illustrate first the given. So let us draw a cube. So this will be our cube. And a hollow sphere is inscribed in a cube. So to find the probability that X will be chosen inside the sphere, we are going to use the formula probability is equal to the volume of the sphere over volume of the cube. The volume of the sphere, that is 4/3 pi r cube. And the measure of the radius of the sphere, that is 5 inches. So we are going to have 4/3 pi, and then we have 5 raised to 3. Let us simplify. Let us have 4/3 pi. 5 raised to 3, that is 125. And 125 times 4, that's 500 pi over 3. And the measure of pi, that is 3.14. Let's have 500 times 3.14 divided by 3. 500 multiplied by 3.14, that is 1,570 divided by 3, that is 523.3333. I'm going to use 4 decimal places here. And then the formula in finding the volume of the cube, that is S cube. So this will be 12 inches raised to 3. So this will be 12 times 12 times 12. That is 1,728. Now, to find the probability that X will be chosen inside the sphere, this will be 523.3333 over 1,728. If you are going to divide this one using your calculator, you are going to have 0.3029. So the probability will be 30.29%. So this will be the answer for letter A. And to find the answer for letter B, there are 2 solutions. First, let us have 100% minus 30.29%, and that is 69.71%. So this will be the answer for letter B. Or if you want to use the formula, this will be probability is equal to volume of the cube minus volume of the sphere divided by volume of the cube. Volume of the cube, that is 1,728, minus volume of the sphere, that is 523.3333, divide by 1,728. So let us simplify. If you are going to subtract this one, you are going to have 1,204.6667 divided by 1,728. 1,204.6667 divided by 1,728, it will give us 0.6971, or if you want to write this one in percentage, this will be 69.71%. So we come up with the same answer. So I hope you've learned from this video. Thank you so much for watching, and God bless us all.